Hello everyone. Today's session webinar is about platform engineering. But before that, let me introduce myself. I'm Prashant. I've been in the platform engineering and DevOps space from past 10 years, helping out major banks in UK and telecom services in bringing automation like provisioning environments and things like that, and also work with many architect architecture as well as application architects, and so I understand the pain points of the engineering team and where platform engineering can help. And let's talk about that. Let's go through platform engineering. Before trying to understand what platform engineering is all about, let's also try to understand what challenges modern engineering. When I say modern engineering, all the new practices that we are following now to an application development, it provides a lot of flexibility to development team in terms of how can make the code changes and then take it to production. But also screen of this page. Okay, so like I was saying, so engineering gives a lot of flexibility to the way developer can build and ship a product. There are many different paths, and that also sometimes become very overwhelming because previously there used to be main core focus of developer was to just take the business requirements, features, and of course there will be non-functional requirements as well. But the focus was still on delivering the feature. But now the same developer now needs to deal with not just building a UI or API or something like that, and then also need to worry about how does that local code change gets built on some remote server. When I talk about that, you can correlate it to Jenkins, for example, but Jenkins is just one product. There might be other CI products. So then depending on what is being used, developer may need to learn about that. How do we configure? Because we also use pipeline as code and things like that. Because of those principles, developer needs to learn the syntax of that, and then again how the application packages are built and deployed, and how the dependencies are all sorted. Because now the modern application development, we don't store all the dependent libraries locally or on a repository. There is a dependency management facility available. For example, there is Maven dependencies. In the same way, each programming language has its own way to manage the dependencies. And then because there are dependencies, then there need to be a tool to manage those dependencies. For example, you can correlate it to Artifactory. And again, once the application is built, depending, typically we might want to deploy it cloud. In that case, we may or either cloud or cloud-like facility. Then we may need to package it as containers, and then we need to think how do we store those images, and then we may need to manage or maintain a container registry. And then, of course, once the image or the package is there in the repository or registry, then we need to have a automated mechanism to take that to production, which is the CD tool. You can kind of correlate it to Spinnaker as an example, but again, I'm just putting one product, but there can be different product, and the engineering team can pick and choose these products, but again they need to be glued together. And then again, where do this gets deployed, application, where will it be deployed? Is it going to be cloud Kubernetes, or is it going to be on some other private cloud, public cloud? And depending on those things, again, there might be additional complexities involved, like how do we configure something to be deployed to Kubernetes. If it comes to Kubernetes, then we may need to work on Helm configuration and things like that if we are using that path. But again, quite a lot of options there to deploy to Kubernetes as well. And then again, monitoring, there are a set of monitoring tools. All of them, we need to understand how they need to be, the application needs to be monitored, and if there is any special configurations required to be done to the application that's deployed. Also, we may need to do some kind of dashboarding, alerting, and everything. And then again, if we are going something on top of Kubernetes, if we want to manage our APIs as service mesh, then again that adds its own additional complexity in terms of how do we manage, monitor, and how do we manage those services? How do we do the deployment of individual microservice if it comes to microservice? And again, on top of this, again, all these tools, right? For example, Jenkins, Artifactory, and any other open source or bespoke tools that we need to use. those also need to be deployed and they need to be available for development team to work on, so that they can focus again on the core responsibility of our development team, which is to deliver the product. So that's where you can see that there is a chance where that burden of the development team can be shared, and that's where platform engineering comes in. So platform engineering is a practice, and also we can talk about it as a team, but also just like DevOps is a practice, we can name platform engineering or as anything. Sometimes some people call it cloud center of excellence by various different names, but it's more on what that team will do. That team will act as a enabler for other teams platform requirements. So anything, when I say platform, it's a very generic term. Platform, when I talk about here, is a particular organization might decide to deploy applications onto a kind of a infrastructure, and then they want to deliver all their teams. Organization might have multiple value streams and things like that, so those teams needs to deploy the applications in a consistent way. That's what as an organization they would need actually. Otherwise there are 10 different teams each doing their own way of deployment, then it becomes difficult to manage, so they may want some consistency there. So then that means all the teams might have similar kind of requirements, and then it would be easier to have a single team managing these platform requirements. And also the requirements again can be spanning, like it can either be like spinning up a cloud infrastructure, for example spinning up Kubernetes cluster. It could be deploying CI/CD tools. It could be anything, and in fact, it can also be how do a new team who wants to use that platform needs to be onboarded. It can span from. It depends on the size of the teams and how many teams are there and what is their core competence. But again, any platform requirements, how do we cater is taken care by the platform engineering team. And also, platform engineering team, like I said, shares the burden of development teams from managing the infrastructure, and so that the development teams can focus on business requirements, delivering quality features, and as quickly as possible and efficiently as well. So, and then the remaining bits about infrastructure, how application should be deployed to an infrastructure and how that infrastructure itself is built can be again shared by the platform engineering team. We can visualize platform engineering team as building a layer of abstraction to underlying infrastructure, and so that development team doesn't need to learn new tool chains because of a lot of things that are changing in the engineering practice. So they might be like a particular tool that is favored, but again when there is more usage of that tool, people might realize that that tool is not doing what is up. It's not doing or it's not up to the mark. Then people might or the teams might choose to use some other tool. But in principle, all that development team would need is a mechanism to take their code built, which is built locally, to production. So that path, typically development team wouldn't worry too much about it. Of course, as understanding, they might be still enthusiastic to know about how it's all done. But for a development team, the focus is how quickly I can change my code locally and how quickly I can take it to production. So that's the thing. So, and then platform engineering team will make that path smoother for the development team. So again, it depends on the amount of demand is there. So platform engineering team can also build like self-service tools using which developer teams can set up their own infrastructure very easily, but without needing to know the details of how the underlying infrastructure is built. So with like, for example, I can give an example where we can have a configuration file as YAML or something like that, and then that configuration file can have the details of what exactly is needed, and we can build on the backend as a platform engineering team all the necessary tools. It could be Terraform modules which will do it, or it could be Chef, or combination of all the scripting that is there. But from the development team's perspective, they just give a specification saying I want these things in my infrastructure, and then that can be automatically built using the tool chain that, so like platform engineering team can again follow the GitOps principles to manage the code as infrastructure as code, and also they can use Terraform, Chef, and Ansible and scripting to hide all the complexities of infrastructure, like I said. So like from developer perspective, all that they want is like, okay, I want Kubernetes cluster with whatever is the detail, and then everything else kind of is transfer is basically like they will just say the specification and it will be built for them. So and also a platform engineering team, like I said, there might be multiple teams who want similar kind of requirement, then platform engineering team will provide a consistent way to provision those infrastructure. So they might have a lot of run books provided, and also there might be automation and things like that. It depends on, again, like I keep stressing that all of this doesn't need to be done on a single day, and depending on the requirement, the platform engineering team is going to be very fluid enough to take and say, okay, how this can be done because we may need to implement tooling and it might take an year to build. So then obviously then it doesn't serve the purpose. So you need to find a balance. That's where it comes in. Yeah, this is again pictorial view of what a platform engineering team. So also just note that I just separated out like SRE and SecOps, but again, depending on the situation, there is no clear boundary there. So there might be an overlap. For example, there might be some DevOps specialists, they might sit in the platform engineering team, and there might be some DevOps specialist which might be shared in the development teams. Again, monitoring and SRE can again be shared between the platform engineering, SRE, and things like that. And just representing here what platform engineering team can do. But again, the boundaries are very blurry and they can overlap with other teams as well. So here you can see that platform engineering team, the customer for platform engineering is twofold. So the end user is obviously customer for platform engineering team indirectly, but directly it's mainly the development teams who are the customers, or the engineering team to be precise. So like it could be SRE team who may want monitoring tools, and then in the same way SecOps a team might want to monitor the code for any vulnerabilities and things like that. And then the Docker image that is deployed, we may need to do run some scan, and then for that again we may need some validation tools, for example. So that all is taken care by the platform engineering team. So for in this example, for instance, development team might just focus on delivering the business requirements, whereas platform engineering team will provide tools, accelerators, and everything what development teams would want, so that they can deliver the features as efficiently as possible. Development team themselves can do the provisioning, but again, like I said, platform engineering also can provision the platform on behalf of the development team. Depends on the maturity level. In the same way, there can be like CI/CD infrastructure that needs to be provided. There are different models. Each development team may want to have their own Kubernetes cluster, for example, or depending on the situation. So there might be a single Kubernetes cluster which needs to be shared across multiple development teams. Depending on the need, platform engineering team will set their goals accordingly, and they will work with the development teams to make development teams' life easier and more efficient. So like I was saying, so I just listed only a couple of goals, but again, keep in mind this is just an example, but again, depending on the requirements of the engineering and development teams, these goals might vary. So and also it's very important to maintain the right abstraction level, because if we have like very opaque view of the infrastructure, then development team might not even understand what is going on. So like if the development team is more mature enough to get to know more details, maybe it might be like, okay, development team might say, we will manage the Kubernetes cluster. We just need it to be provisioned. So that is one way. The other way is they'll say, okay, I can provide details, and then the remaining things can be done by. So the goals are very dynamic, and also the key thing is platform engineering team should be able to adapt their team based on the need and at that point in time. Same thing again, we may need to, like as a platform engineering team, may need to develop some tools that can generate the metrics that will help us to again measure our outcomes. And also, there should be like, we need to set up a feedback loop with the developers and all the stakeholders to make sure that the team is actually catering all the needs of the engineering community. Again, outcome, how do we measure the outcome? So obviously, we need to again decide and define our KPIs, and then based on those KPIs and then measuring using the tools as well as like feedback that we get from developer and engineering teams. So then based on those outcomes, again, we can reorganize our goals to deliver efficiently the platform needs of the engineering team. Then again, if we are trying to set up a new platform engineering team, there are some things that we need to be very cautious about, because otherwise it might not actually do, uh, it might it might actually do more harm than useful actually. So that's where it's always important to establish a clear purpose to build a platform engineering team. What is the reason behind building the platform engineering team? So that purpose needs to be clearly defined, and what are the immediate problems that the team needs to solve, and what are the problems that needs to be solved down like 6 months or an year and things like that. So, and also roles and responsibilities, again, like I said, it is going to be very dynamic, but it's also very key to say, okay, what will be the role of platform engineering team, and what needs to be done by the other engineering teams, and what will be this collaboration. So because I said this team will share the burden, that needs to be clearly defined. Okay, the is the team gonna just build the infrastructure, or is it gonna configure that, is it gonna build a self serve capability and things like that. All that roles and responsibilities needs to be established before we set up this team. Again, like I said, clear boundary with other engineering teams is also very important, and abstraction between platform and the other teams, that again needs to be clearly defined, saying, okay, do we want to just make it very opaque, or it should it be like slightly translucent, and then there should be slightly more overlap and things like that. All this is very important when we set up platform engineering team. Of course, again, it's also important to prioritize all the current platform challenges and bottlenecks and pick whatever are the main pain points, rather than just saying, okay, I will start building a self-service portal for developers, while there is another more prioritized issue that needs to be solved before we move to the self-service capability. So that's where important to prioritize the challenges, or what problems are there before the team can be formed and start working with other development teams. Yeah, so that's all I wanted to cover. Thank you everyone for joining this session.